Good afternoon. I'm Alex Hong. I'm a kernel and a hardware-enabled engineer in Connecticut. And before I became a kernel engineer, I was a firmware engineer, like working for the ODMs. And I'm also a maintainer of the firmware test suite, which is the testing tool that I'm going to present and share today. So this is a short agenda. First, I'll give some introduction about the firmware test suite itself, and then about its framework and some features, and of course how you can install and get in a source code for the firmware test suite, and give some introduction on how you can use it, and also how you can use for the SBBR. SBBR is a specification for server. So before talking about the firmware test suite, I'd like to talk about this slide. And the screenshot was taken from a YouTube channel I like a lot. So the YouTuber is trying to show how you can make a grilled cheese. And he started from making bread. And he used two different approaches, not exactly. So first he used measure the ingredients by volume. And what he got was something on the left, like the small tiny bread. So he then, after a few iterations, he realized that he should try to do something different. So he measured the ingredients by weight, and he got what's on the right side. And so you can see as simple as measuring, you can get significant different results. So I think the same philosophy also applies to the engineers, to what we are doing right now. So we know all of the specifications, but how do we know we implement this specification correctly? So our solution is to have a testing tool, of course, always testing tool, that can check what firmware implement, what kind of functions firmware implements and also provides. So essentially what we do is we take the specification of software specification, firmware specification, hardware specification, and take the specifications and implement a tool that check what they have provided against firmware's implementation. So the tool runs in Linux, and it is open source at GPL v2. And not only that, it's after years of working hard, we now get promoted by the tool has get promoted by the UEFI forum as the recommended ACPI SCT. And UEFI forum, as you might have known, are the owner of the UEFI and the ACPI specs. So this figure shows what firmware test suite is capable of testing. For example, you can test the ACPI spec, also the legacy BIOS on the PC, on the device tree. You also scan the kernel log for the firmware-related errors, and so on, like SN BIOS, OPL, or MPCI, UEFI, and so on. And for some of the tests, you can also have sub-tests. In the case of the ACPI, because ACPI is more like a table-driven, everything are implemented as a table. So for each table, we have a test for the table. And in some cases, we also check between the tables. And we also have a check for for all the tables, like the checksum, and the integrity of the check tables, like checksum. In the case of the UEFI, UEFI is composed of the boot time service and runtime services. And for obvious reason, because we run in Linux, right? It's the OS. We couldn't have the FWTS to check the boot time service. So we check most of the runtime service instead. Or I say most because there are some tests, there are just some runtime services you cannot check. For example, the reset. You can't just call the reset runtime because you just reset the system and nothing else will be saved. But for the most part of UEFI and ACPI, we try to do everything as much as we could. And of course, FWTs are heavily relied on the Linux kernel. So everything was, every check, every function goes through the Linux kernel. So if you want to check a PCI, we go through we use the PCI subsystem. If you want to check SN bias, we go through the, actually we do two things. We go to the memory and get a table and also compare against which others. Two most particular different ones are the ACPI and the UEFI again. And the ACPI, we go through the ACPI CA subsystem and get the ACPI information, the tables and so on. In fact, we also integrated a copy of the ACPI CA in the FWTs in case we need to run in some emulation, run some tests in the emulation mode. And for the UEFI part, we have one of the other maintainer implement kernel module called EFI test. That's available in the Linux kernel tree already. Or it's not enabled by default. So if you can just, if you want to run the EFI test, you can just enable this kernel module. If you don't, there's another solution will be, we also have a kernel module in our FWTS package with slightly different name called EFI runtime. And if your kernel does not enable EFI test, you can manually compile the EFI runtime module in the EFI, in the FWTS and load it during the runtime. So install FWTS is quite easy, especially on the Ubuntu and the other Debian-derived distros. It's like you add a PPA. You can just do app update and the app install FWTS. Or if you want a simple GUI interface, you can also install the FWTS-frontend. On the other hand, I know it's not if you don't run the Debian-based system, you can always clone the source code from the kernel.ubuntu.com. But we also get some report that if you try to access the kernel ubuntu.com from China behind the Great Wall, then you might have problems. Then you can use the GitHub. They are mostly synced. Maybe there are a couple have our differences, but they are mostly synced. Then once you get the source code, you can just run the make and the make install. Then it should just install everything. So the interface is quite easy. It's just like a command line tool itself. So if you want to run a FWTS with a single test, you just append a test name behind the FWTS. Similarly, if you want to run multiple, like 2, 3, you just append each different test names behind. And for some of the other, like we also try to make a group of tests so you can run them easily. For example, if you want to run all of the ACPI tests, you can just use the --ACPI tests. And if you want to run all of the UEFI tests, you can just use a --UEFI tests. And the documentation is always available in the application itself. You just run the show test for. You can see all of the detailed information of each tests. So we know some people love GUI, maybe not developer like us, but there are some people who prefer GUI interface than the command line. So we do have a simple GUI interface called fwts-frontend, which is a front end that passes the user selection and generate a command line to the FWTS, pass down to the FWTS itself. So this is it's very simple. It's like with a predefined selections of the tests you can run. Like we have a selection called the ACPI and one called UEFI. And the recommended is like a combining of the UEFI ACPI with many other like CPU, DMI information, and so on. That we used for when we are working with the BIOS upstream or the firmware upstream. And of course, you can always select each individual ones. That's the second from the button, select it. You can always select the one you choose to run itself. So, for SBBR, SBBR is one of the ARM specification that defines the base firmware requirement for out-of-box support for any ARM SBSA compatible operating system or hypervisors. So in the spec, it asks for support for the ACPI. That's a check in the FWTS. It asks for the support for the SN BIOS. That's also a check in the FWTS. And of course, it asks for the UEFI, which is also a check in the FWTS. So one of the ARM developers sent us a page that reuse everything we have, reuse a lot of things with their code as well to create a special command line is like called --SBBR, just like the one we have for the ACPI and the UEFI. So if you want to run the test for the SBBR, you don't have to write a lot of tests. Instead of you can just write fwts-SBBR. Of course, SBBR is not just about like 3 ACPI, the ACPI, SN BIOS, and the UEFI. It's actually a subset of it. So using this command, you can do a more fine granularity of the test for the SBBR. So that's a result log generated by FWTS on an ARM server. So like on the very top is a version of the FWTS. It's like in this case, it's a 1907.00. And in the middle is like the system you are running, like which kernel you are running, and so on. And followed by a command. It's like a command, like in this case, we run the fwts-SBBR. So that's the command like the user manually selected, which will be expanded to the actual test that runs on the system. So you will include like a DMI and with a bunch of the ACPI tests. And followed by the expansion of the test is the detailed information of each test that's been run, including the failure. If you see a failure, you will also get the detailed information like or some suggestions on how can you fix it and what kind of failure you have seen. For example, in the ACPI, you have a package that's should return integer, but you return the package instead. Then you will see like it complains, okay, you return something incorrect. Or if it's an integer, but it's out of range, you also say, okay, the return is out of boundary, and so on. On the very bottom of the log file, you will have a summary, like what kind of failure you have. Like you can have a critical failure, high failure, low failure, and so on. And on the very bottom is a summary table with the kind of what tests you have run and how many passes and how many failures. In this particular system, you will see 2 failures for the GTDT table, ACPI table, and 1 failure for the method test. So okay, that's pretty much it for how do you use it. How to use FWTS and what is capable of. So, but also like we would like to show like our mailing list. So you can always ask question on like how do you use it, or what kind of support you can provide, and what kind of extra feature you want. Or you can. There's also the same link you send pages to. So, and we also have a website with the detailed documentation of each test, like what kind of tests are supported, and what it does. And maybe in some cases, we also provide some reference to the failures as well. And you can also follow us on the Facebook and the Twitter. And we also, if you like to face-to-face communication with us, the UEFI Plugfest is the best place to go because we attend UEFI Plugfest regularly. So we take our tour, we go to the firmware upstream, we run the tour, complain enough so they cannot ignore us forever. And we kind of success, not completely, but we kind of do a good job there. So now we are seeing fewer failures for the Linux systems. So okay, that's pretty much it. So if you have any questions, I'm here. Sure.
Yeah. Hi.
Hi.
This is great. So how amenable are you to people adding tests to your test suite? So my understanding is that you have two things in what you described, right? There's a framework to write tests, and then on top of that, you're writing tests to test for specific, things like ACPI compliance or SBBR compliance. Or so imagine I work for VMware. And for our software to run servers, for example, we might have specific requirements on ACPI tables, for example. Like maybe the standard says this table can be optional, but to run our software, we need that table. If it's not there, we cannot run, right? Okay. So if we wanted to add our own tests to your framework, would you be amenable to us creating a subdirectory to test for compliance for something else that's not SBBR or ACPI, but that's VMware specific? Yes. Or would we have to fork your project and add our own tests and tell our customers in order for them to validate their hardware to use our tree instead of yours? Like how open are you on that?
Well, you can, as you say, you can always fork our tree. And of course, the best thing will be contribute to ourselves. But I do understand in some cases you do not want to share what you are testing. There is no best solution. It's like any other open source software. Because it's GPL or B2, right? Yeah. And if you don't sell we like to see people contribute to ourselves. But it doesn't stop you using it as an internal project, right? So you can still use it. And well, in most cases, if you just want to select particular test that you are running, you could just use a batch file, let run particular test. But if you want to do something a bit different, like for example, the range is from 1 to 1,000, but you are targeting only 1 to 100, then I guess then you have to multiply that source code. Well, the other way is okay. Also, you can maybe say, give us a patch, have a parameters, then in your script, you specify the parameters. They will do as well. So I guess there are also something you can do without sharing your secret.
I'm not too worried about secrets in that particular case, right? I'm just saying, if we had our own tests, they are very specific to my company. So what value does that add to your tree? It's great if we can put them in your tree, right? It seems simpler, but it adds little value because it's something that we can share, but it's not very useful to other people to reuse. Yes. Outside of our customers.
Yes. Yeah. I guess, so like I say, I don't have an absolute.
And that's a perfect answer, right? I don't know. We have not seen the case yet. Is a perfect answer, and that's fine.
Yes. Okay. Thank you.
So there are quite a few places, certainly some anyway, where the ACPI spec, for instance, allows a lot more flexibility than the kernel will actually interpret. So they disagree. Do you specify, for instance, that the kernel's always right? Or?
We actually compare what's written in the spec. We don't really, let's say this, we compare what's in the spec and generate what's failure is if it's auto-defined in a spec. But in some cases, we do return lower severity failures if the kernel doesn't care. So yeah, I guess does this answer your question?
I mean, a classic example would be SLIT, S-L-I-T. The kernel insists it's symmetric, the ACPI spec doesn't. So
currently, for this particular test, it's only compared to the what spec says.
Oh, okay.
Yeah, this current, but if you have any other suggestion, you can always email us, tell us what do you think, and then maybe we can kind of arrange it for it, maybe do something different. Cool. For example, in the recommended test, we do something differently. You actually implement a switch case for ODM, for OEM. There will be, they do things more they do care about something. For example, they care about the ESM BIOS entries because they are shipping out information, right? But for the firmware vendors, they are just giving you references. So that's also one thing you can do. It will generate severity based on different needs.
Sounds good, thanks.
Thank you. Okay, I guess that's it. Thank you.